Alright, so I think there's a lot of confusion as to how a PCV valve actually works. So I did the video the other day of how to change the PCV valve. If it's getting sticky, it's not opening and closing properly. I did it basically just because of preventative maintenance. It's been in there a long time. I have no idea if the previous owner even changed it. So, and the boots around the PCV valve were all cracked and leaking. So just residue, oil residue coming out. So I decided to just change them up. So, but I'm gonna kind of try to explain how the PCV valve actually works, and a little bit of a visual aid here for you. Alright, so here we go.
Okay, so here is just a little diagram. Basically what we have here is it's going to show you what positions the PCV valve is in at different engine speeds and basically engine vacuum, because that's basically how it works. So here you have, we're at idle speed, so the PCV valve basically, it's going to use both ends of it. You'll have this end here, and that's basically going to, and it's also going to use this end here, kind of cone shaped, and that'll actually determine how much air is flowing in and out. So as you can see, I mean, the diagram kind of tells you exactly how it works here. At idle speed, you're going to be at your highest manifold vacuum, and it's basically going to work against the spring that's in there that would normally be holding it closed. It's going to pull that spring in the direction of the vacuum. Well, it's going to pull the valve in the direction of the vacuum against spring pressure, and it's going to basically bring that valve as far over as it can go, restricting the flow at high manifold vacuum at idle speed. So you have less blow-by, you have less pressure causing all that blow-by at low idle, or at idle, and at high vacuum to shut that valve. So the engine doesn't have the blow-by, so it doesn't need to vent all the blow-by. So at idle, simply it closes off the valve and restricts that extra flow coming into the intake, which would basically cause too much air volume coming in versus the fuel mixture that's going to be coming in. At high speed, so when you're thumping on the throttle, you're basically going to start to have less manifold vacuum, which is going to basically allow that spring to open the valve more, because it doesn't have that manifold vacuum working against it anymore as much. So that spring is going to be opening the valve against vacuum pressure, which allows more area basically at the end of the valve. It allows more airflow through. So as you can see up here, you have the whole valve area basically allowing, or not allowing any air through, but here we have less valve closing that orifice, so you're getting more airflow through coming from the crankcase. So there's your blow-by, your crankcase pressure is going to be relieved due to all that airflow now. And then basically down here, and I mean when you're at medium throttle, obviously you're going to be kind of in the middle there, hovering, you're going to get medium flow. Down here, it's showing you a case of a backfire situation. So if in the event there's a backfire in the engine and it comes up through the intake and it's going to try to go back through, basically it's just you're going to have no vacuum at that point. So you're going to have no flow, because that spring is just going to go straight over to the right on this diagram, and it's going to close off that orifice leading from the crankcase. So you're not going to get any backfire coming all the way through the line and going all the way back down your crankcase and basically igniting all your oil and gases. It won't happen. Well, that's the idea anyway. It won't happen because of that shutting off due to the spring pressure having no vacuum against it. It'll shut off. So that's kind of the rundown of how it works. Obviously different vehicles have different systems. They'll have lines that come in from the airbox to provide clean air as well, to mix with the blow-by gases, so it's not just, you know, steady blow-by. Other systems don't even have the PCV system. It'll be kind of integrated in a different way on newer vehicles. So I guess you could say they still have it, but it's just a different type or style of system, may not have the actual valve. So that's kind of it in a nutshell. This system, if it gets gummed up, Obviously you're going to have issues with it. You know, if it gets all tons of oil in there, it's going to be closing on, it's not going to close off at the right time, or it's not going to be able to move properly in there. It may not slide back and forth properly. That's when you're going to start having issues. And if it's totally blocked off, then you're not going to be venting your gases in your crankcase, which can basically lead to oil leaks. The pressure builds up and the oil starts to leak past your pan gasket and things like this. So it's good to keep them changed. They're cheap, usually $10, $5. So you might as well just throw one in every now and then, maybe once a year, or once every other year, depending on who you are. But alright, so I hope that clears it up a bit, and we'll see you soon. Bye for now.